Hi, this is your first recording to watch for Chapter 2, The Scientific Process for Physical Science. We are entering into talking about scientific processes that involve the scientific method, the experiments that go along with that, and the variables that change, and also the nature of science and technology. So there are 3 parts to this chapter. This should all be reviewed because you guys have experienced the scientific method for many years prior to your physical science class. So we first want to look at inquiry and the scientific method. Scientists believe the universe follows a set of rules called natural laws. Natural laws meaning natural, that they take place on their own without any help. Gravity. Gravity is a law that scientists discovered because it's something that happened. Newton's sitting under the tree and the apple fell. Where did that apple come from? What made it fall? So the primary goal of science is to discover these natural laws and what they mean. So just by sitting there wondering what happened and how things happen have brought so many discoveries into this world. Learning about science by asking questions is called inquiry. This goes back and relates to the cup that was sat on your desk on the first day of school. The Dora and Diego cup. You walked into class and you saw the cup sitting on the desk, and you might have thought to yourself, why is there a cup there? You might have picked it up, you might have touched it, and you might have played with it. All because you were curious, because you were inquired about why there was a cup on your desk. The same thing with a crime scene investigation. Okay? Everything is science. You ask a question, you wonder why, you try to find the solution to it or find solving the mystery. Okay? So we look at this and it leads us into scientific evidence. It must be observable, meaning you have to make an observation. And when we make an observation, we make it with our 5 senses. And we all know our 5 senses. We can see it, we can hear it, we can taste it, we can touch it, or we can smell it. Objective means that the evidence should be described what actually happened. So you have to be able to see it. You have to be able to taste it, touch it, as exactly as possible. So it meaning that it's reported without bias or opinion. That means that is subjective. That is not giving true evidence. And there are a lot of sciences that will do that, and there's nothing that can hold that accountable. So scientific evidence must also be repeatable, especially to be believed. If you don't get the same results over and over again, then it's not going to be upheld. Scientific evidence may include numbers, tables, graphs, words, pictures, sound recordings, or other information. So you have your sound recordings when I talked about hearing. Okay, pictures, what you see. Okay, other information that's gathered. Could be gathered by you or by others and evaluated by them. Scientific theories. So, looking at scientific theories, it's a human attempt to describe a natural law. The word theory in science means a single explanation that is supported by lots of evidence. Okay, supported, lots of evidence over a long period of time. So just an idea that's come up and tested doesn't become a theory right away. It happens over time. And it may be multiple scientists, as you read in the article that we read at the beginning, that there were multiple scientists that might have found the same element but didn't get credit for it. but proved that it was what it was, so they got the credit. But theories in science start out as hypotheses. Okay. Hypothesis. So if we're looking at an example, suppose heat is really a form of energy, then we would not have any mass. And this kind of goes along with an idea that's presented in your book referencing heat. A scientific hypothesis must be testable. So when you're thinking about this for your final project in the honors class, it has to be something you can do an experiment on, collect evidence, and prove or disprove. So supports or refutes a hypothesis. If you can't do that and come up with a test, then it's not valid. Okay. And here they do an experiment here that they reference about seeing if heat might be energy. Big controversy of what you think. It's a big misconception that we'll talk about later. When we look at a hypothesis, and we all know that that is one of the things that's part of the scientific method. The scientific method is the underlying logic of science based on evidence. Okay. So the key thing here that we're looking at is it's all based on evidence. So you have a chart similar to this that you're going to fill in and add notes on. The first step of the scientific method is making observations of nature. Okay. Again, observations are made with the 5 senses. Then we have step 2. Develop or revise a hypothesis. Now, the first time you go through this, it's going to be, oops, gotta go to pen. It has to be develop. Why it says revise a hypothesis is because this is typically not a linear avenue. Once you come up farther down up the steps, you may have to go back a few steps and start all over again if things aren't looking like they're supposed to. So hypothesis, you hypothesize about how things work or tested against evidence collected from observations and experiments. The key thing with the hypothesis is a lot of people think that it is an educated guess. That is not true. A hypothesis is a possible answer to a problem. Step 3 is testing by observing and experimenting. If the hypothesis correctly accounts for evidence, it becomes a potentially correct theory over and over and over again. So the key thing here with your experiment is that it must be a controlled experiment. So we have a controlled experiment, and in a controlled experiment you have your controls, but you also have your variables. And the key thing with variables is you only ever want to change one at a time. If you change more than that, then you're not going to know what really caused the outcome of the experiment. It's kind of like having a headache. Okay, do you have a headache because you're tired? Or do you have a headache because of your allergies? So if you take an aspirin and an allergy medicine to get rid of your headache and your headache goes away, well, do you know it was from the aspirin or from the allergy medicine? You don't know because you changed two things. So you have to test one thing at a time. And that is key to also take into consideration for your project. If everything is proven in the experiment and you get good results, step 4, theory, a human attempt to describe a natural law. A theory is continually tested, though. Theories can change, so they are continually being tested by other scientists, so they can disprove or debunk the theories that are out there now. And that's key for people to understand. And the last one we have is testing. By collecting new and different evidence. If theory doesn't explain new evidence, even one single piece, you have to go back to step 1. And that's what we are referencing over here, is revising your hypothesis. So you have to revise it, go back, you're going to make observations, you're going to go through a whole new experiment and change things up, possibly. So that's what we have to remember, that the steps don't always go in step 1, step 2, step 3, step 4, step 5. And depending on what the question is, you may not do testing because you're using another scientist's data. So you may just be analyzing and then coming up with your conclusion. So we have to be objective with the scientific method and make sure that it is repeatable. Here's an example of the scientific method. Your car don't start. Okay, why? Well, you formulate a hypothesis. Maybe the battery's dead. So then you design and conduct an experiment. You try to turn on the lights to see if they work. Well, if they work, then it must not be the battery. So, but if the lights go on, then the battery is okay. So you test the conclusion, or if necessary, refine the question and go through each step again. So you have to go back and think, was it the battery? Was it ignition wires loose? Was it gas? Each of them is a new hypothesis. You're only going to do one at a time. Process of elimination to find out what the cause is that the car doesn't start. Okay. So here you can kind of see that the arrows go back and forth in this diagram here. Oh, pen. And also we have a circular process. Think, try again. And that's one of the key things. And that is what Thomas Edison said. I didn't stumble 1,000 times. The light bulb was an invention with 1,001 steps. A lot of scientists didn't discover their things on the first try. And they didn't intend to, some of them didn't even intend to discover what they did. They did it by accident and then had to try to repeat it to make it valid. So that is the scientific method. We will be doing some activities to support these steps and this information that we have covered here in class. If you have any questions, be sure to write them down and bring them to class for me. Thanks.